Hi, A&Pers. This is Dr. Jones checking in. This is A&P1T5 Neuron Anatomy. We're going to be drawing a picture of the neuron, and I have our kind of base drawing here. We have this is a neuron, and the cell body is a soma. Let's see if I can do that with the thing. Okay. And then the axon, zoom in. Oh, that works. Okay. And then, of course, oops, you know, these little knobs at the end are synaptic knobs. Or synaptic terminals, axon terminals, take your pick. Okay. So the other structures we need to know are the dendrites, dendritic trees, and these are like trees, branchy structures I can't draw, so we're just going to pretend like that makes sense. And let's see, let's label these. And the dendrites receive information. Also need to draw a, let's see, nucleus. I guess I didn't label the nucleus. Let's do that. And let's draw a couple of nucleoli. A couple of three. L-E. Nucleolus. Oops, it's plural. So nucleoli. Dot. There, too. Okay, now let's draw a mitochondrion. Mitochondrion has an outer membrane, an inner membrane with folds called cristae, and then stuff inside the inner membrane called matrix. Label this with black. Mitochondrion. Mitochondrion is the singular, mitochondria is the plural. So we also need to draw some Nissl bodies. The Nissl bodies are RER, so rough endoplasmic reticulum, and what makes it rough is all the ribosomes, hence the dots. So the Nissl bodies are RER and free ribosomes, so we'll add some more dots. There we go. Lots of ribosomes, and what do ribosomes make? Proteins. You got it? Anybody remember where ribosomes are made? In the nucleoli. So the rRNA is made in the nucleolus, and then the rRNA and the proteins are assembled into ribosomes into the nucleolus. In the nucleus. Nissl, capital N, it was the dude's name. Oops, it's not making an L. There we go. Nissl bodies. D-I-E-S. Okay, let's see, what term have I skipped? We've got Nissl bodies. Find this picture in the note set. The carryon. So the carryon, let's find a green. I'm feeling light green. There we go. And let's make it a thicker but less opaque. There we go. So the carryon is everything between the cell membrane and the nuclear envelope. Label that in black. Whoops. Get our opacity back. There we go. Okay. And carryon is spelled P-E-R-I-K-A-R-Y-O-N, but it's pronounced like a paracaryon luggage. It's not spelled like that. And then we need, let's make this one orange. We haven't done orange yet. That's not orange. Okay, we can call that orange. So this area here is the axon hillock. H-I-L-L-O-C-K. And then we need the initial segment of the axon. initial segment of axon. Okay. Actually, let's draw that one in real quick so it's clear we mean this whole region. Okay. All right, so let's review. We have a neuron. We have a soma, which is the cell body. We have the parakaryon, which is the soma minus the nucleus. We have a nucleus. We have several nucleoli in there. The dendrites, which receive information. Oh, still in pink. Okay. Receive. I before E, except after C. Disproved by science. Receive info. Okay. And then the axon hillock is going to be your information processing. Let's see if we can make that thinner. Info processing. ESSING. There we go. Okay. And then the axon sends information. Dendrites receive information. Soma also receives information. The axon hillock is the information processing, and the axon sends information. If you are reviewing this video and you've already studied the rest of the chapter, you will know that the axon hillock, the information processing, is whether or not it can bring the initial segment of the axon to threshold. If you haven't gotten there yet, don't worry about it. You'll see it when you come back to this. So there are parts of the axon that we need to know. The axon membrane is the axolemma. And the stuff inside the axon is, in general, axoplasm, which we'll talk about axoplasmic transport, moving stuff through the axoplasm when we get there. Okay, another term that we have not done yet. When the axon splits to go to the synaptic knobs, the splits have names. So these are not technically called, they're part of the axon, but they're a specialized part of the axon, just like your fingers are part of your hand, but a specialized part of your hand. So these are called telodendria. Okay. All right, well, this has been your video on axon neuron anatomy with Dr. Jones. This is A&P I-T5 material, and I am going to shut this down here and make sure I know how to save these things so that you can see them. The education must go on. Thanks for listening in. Dr. J out.